Okay, the second part, or the second lesson today, we'll look at a function notation, something that we use a whole lot in Algebra 2. Okay, so you guys may have been introduced to function notation in Algebra 1, but in Algebra 2, we use function notation a lot. Okay, and then we'll evaluate graphs of functions. Vocabulary, function notation, dependent variable, and independent variable. So I talked about dependent and independent variable before in lesson number 1. So here, some sets of ordered pairs can be described by using an equation. You're probably used to using the equation like y equals 5x plus 3. Y equals 5x plus 3. When the set of ordered pairs described by an equation satisfy the definition of a function, that is, each x only goes to one y, the equation can be written in function notation. Well, what's function notation? Well, function notation is very simple. We replace that x there, or we replace that y. We replace that y with something called f of x. F of x. Okay. The important thing to remember, though, y and f of x, they're the same thing. Okay, very important. Y f of x. It means the same thing. Okay, but we use function notation, so f of x equals 5x plus 3 rather than y is equal to 5x plus 3. Why do we use function notation? Because it's kind of like crystal clear now that f depends on x. Okay, the function f depends on x. Whereas if I had this here, y is equal to 5x plus 3, is it crystal clear that y depends on x? Well, maybe, but certainly it's a lot clearer to me if I say f depends on x there. And that's what function notation does for you. It makes it clear as to what depends on what. The function f depends on x. Okay. Now, when x is equal to 1, when we substitute 1 for x, we get 5 times 1 plus 3, and so we get 8. We get 8. If f was equal to negative 2, we would have 5 times negative 2 plus 3, and that would be negative 10 plus 3, and that will be negative 7. Okay, that's evaluating a function. All right. Caution, f of x is not f times x or f multiplied by x. F of x means the value of f at x. The value of x. So f of 1 represents the value of f at x is equal to 1. Crystal clear that f depends on x. In function notation, f is the name of the function. The output f of x of the function is called the dependent variable. Remember we said earlier, y is the dependent variable. Y is equal to f of x. That is the dependent variable. Dependent variable. F depends on x. Y is the dependent variable. And then x is called the independent variable. When a function is graphed, the independent variable is graphed on the horizontal axis, and the dependent variable is graphed on the vertical axis. So here they give us an equation. D depends on t. D of t equals 65 times t. Now what could D represent? I bet you it represents distance, for example. And distance certainly depends on time. If you're driving 65 miles an hour, in 1 hour you drive 65 miles. Okay. In 2 hours, in 2 hours you would drive 130. And in 3 hours, what would that be? 15, 18, 195. 195. Okay, so it's crystal clear that the distance depends on time. The distance you travel depends on time. T is the independent variable, and D of t is the dependent variable. Here they graph order pairs 0, 4, 1, 5, 2, 6, 3, 7, and 4, 8. Okay? These are discrete points, so we do not connect the points because they're discrete. It's not like this graph here, where time is continuous, right? We can certainly connect the points because time is continuous. Time is continuous. But here, we have discrete points. so we don't connect the points. A function whose graph is made up of unconnected points is called a discrete function. So let's look at some examples, and these will be discrete functions as well. A carnival charges $5 interest fee and $2 per ride. So the cost you pay depends on the number of rides you ride. Well, if you go to a Carnival Valley Fair and they charge you $5 just to get in, you only spend $5 once. But for every ride you ride, they're going to charge you $2. So here they say cost depends on rides. Okay, so C is cost is a function of R, the number of rides. So C of R is equal to 5. Now, come on, marker. So C of R is equal to 5 plus 2 times R. $2 per ride. $2 per ride. C of R is equal to 5 plus $2 per ride. So if you ride 12 rides, okay, evaluate the function at 12. So C of 12 is equal to 5 plus 2 times 12. Well, 2 times 12 is 24 plus 5 will give you 29. So C of 12 is equal to 29. Okay. A local photo shop will develop and print the photos from a disposable camera for 27 cents per photo. So the cost you pay depends upon the number of prints. So I'll say C depends on P, the number of prints, and then you will spend 27 cents. You'll spend 27 cents per print, per P. Per P. Now they used f of x is equal to 0.27 times x. That's okay. That's okay. You can use that as well. F of x. F depends on x. C depends on P. And then here, if you have 24 prints, then you'll evaluate that function at 24. So f of 24, you just substitute x for 24, and you get $6.48. 24 is the independent variable. F of 24 is the dependent variable. F of x, C of P, dependent variable. Okay, so on Hope McDougall online, you have a couple of problems here, so I just want to go over these so you know how to do them. Okay, so let's say here you have this problem on Hope McDougall. Enter a function in function notation to describe the situation. Find a reasonable domain and a reasonable range, okay? It's important to find something that makes sense here in the context of the problem. Mary has already sold $55 worth of tickets to the benefit concert. Good for Mary. She has $55. But then she has 2 tickets left to sell at $7 per ticket. So here they want you to write a function in function notation. Well, they start this off f of t. The function depends on the number of tickets. And so right here in this little box, right there in that little box there, you would write the function. And as soon as you put your cursor in that function, up will pop this little calculator, which you don't really need to use in this example because you don't have to write fractions or square roots or anything like that. You may want to, if you make a mistake though, you may want to click that delete and start all over again, that trash icon. But in that little green box, what you would write the function. Okay, so that would be f of t. F of t. Now Mary has $55. She already has $55. But for every ticket she sells, she's going to earn another $7, so $7 per t. Okay, so t. The function f of t depends on the number of tickets. So she has 55 plus 7t. So what would be a reasonable domain? Well, she can sell either 0 tickets, 1 ticket, or she could sell 2 tickets. That would be a reasonable domain. Okay. She certainly couldn't sell 1.5 tickets, or 2.5 tickets, or 3, because she doesn't have 3 tickets. But what would be a reasonable range? Well, if she sells no tickets, f of 0 would just be 55 plus 7 times 0. That would be 55. If she sells 1 ticket, f of 1 would be 55 plus 7 times 1. Oops, that doesn't look like a 7. And that would equal 62. And if she sells 2 tickets, f of 2 will equal 55 plus 7 times 2. 14 and 55, that would be 69. So a reasonable range would be 55, 62, and 69. And that's what you would enter there. So you'd enter your function in that little green box, and then of course you check your work. If you make a mistake entering something in the green box, just press the trash icon. Start all over again. Outside of that, you don't really need that calculator that pops up. All right, the next thing here. So here we have a function, f of x is equal to negative 2x plus 13. It has a range, so that's the y values. Remember, the range is y. Range equals y equals f of x. Okay, it has a y values of 11, 9, 5, and negative 1. So f of x, so they give us f of x is equal to negative 2x plus 13. But y is f of x, so I could write this y is equal to negative 2x plus 13. But y is equal to the range. Okay, so if they give us the range is 11, well, that's f of x or y. I just said y is equal to 11. And then let's see here. And then we'll subtract 13 from both sides. And then I'll get negative 2 equals negative 2x. And then I'll divide by negative 2. And I'll get x is equal to 1. And it says select the domain values of the function from the list. Complete the explanation for how you arrived at your answer. So I would select A because A is 1. Okay? And then let's see here, so if the range was 9, or y was 9, or f of x was 9, again, so I would have 9 equals negative 2x plus 13. Subtract 13, you get negative 4 equals negative 2x. Divide by negative 2, and you get 2 is equal to x. So another answer would be B. B is 2. And then you do the same thing for 5 and negative 1, selecting those letters that correspond to the correct number. I substituted each range value into the function for f of x and solve each resulting equation for x. So I substituted each range value into the function for f of x and solved each resulting equation for x. All right, so there you go. And so that's the second part of your homework.